Alright, so today we're going to investigate the relationship between linear scale factor and area scale factor. I'm going to take a look at various rectangles and a couple of different scale factors to try to see what the relationship is. So let's take a look at our first one. Our first rectangle is 3 by 5, which gives us an area of 15. And there's a scale factor of 2, which is greater than 1. Anytime that you have a scale factor that's greater than 1, you are looking at an enlargement. So you take your scale factor and you're going to multiply it to each of your dimensions. 3 times 2 divided by 1, which is 6, and then 5 times 2 divided by 1, which is 10. You can take each of those two new dimensions and find a new area. Now you can find the scale factor by taking the new area and dividing it by the original area. You can simplify your fraction to 4 over 1 or just 4. Now take a look at this number 4 and see if you can determine a relationship between this area scale factor and the linear scale factor. We're going to continue to the next rectangle. So our next rectangle is 9 by 6, which gives us an area of 54. And we have a linear scale factor of 1 over 3. This number is less than 1, which means that we will have a reduction. You can take each of your old dimensions and multiply them to your linear scale factor to get your new dimensions. So 9 times 1 divided by 3 is 3, and 6 times 1 divided by 3 is 2. You can determine a new area by multiplying your dimensions to get 60. Finding our scale factor, we take our new area and divide it by our original area. Simplify this fraction by dividing both the top and bottom by 6 to get 1 over 9. Now, when we take a look at this 1 over 9, let's see, if we were to square root both the top, square root of 1 is 1, and the bottom, square root of 9 is 3. Now, that 1 over 3 is the same as our linear scale factor. Let's see if it works for the top one. We had an area scale factor of 4, and if we square root 4, we get 2. And 2 times 2 is 4. Our linear scale factor was 2. Okay, let's keep going to develop this understanding. So our next rectangle is 4 by 8 with an area of 32. And we have this linear scale factor of 3 to 2. Because neither the numerator nor the denominator are 1, we are going to have to maybe use proportions to help us to find the new dimensions of the rectangle. Remember that for scale, you always have new over original. So our scale factor, 3 to 2, is equal to our new, which is not known yet, over our original, 4. Cross multiply and divide by 2. 12 over 2 is 6. Do the same thing with the other dimension. 3 to 2 is equal to your new dimension over your old dimension. 3 times 8, cross multiply, and divide by 2. 24 over 2 is 12. Multiply to get 72. So your new area, 72, over your original area, 32. You can simplify these by dividing both the top and bottom by 8 to get 9 over 4. If you were to square root 9, you'd get 3. And if you were to square root 4, you'd get 2. Notice that 3 over 2 is our linear scale factor. And if you take that 3 over 2 and squared it or multiplied it to itself, you'd get our area scale factor. Let's try our last rectangle. So you've got these dimensions, 3 by 12, to get an area of 36. The scale factor does not have either the numerator or the denominator as 1, so you might want to do proportions. This number is less than 1, which means that it's a reduction, and scale is always new over original. So 2 over 3 is equal to new over original. Cross multiply, divide. 2 times 3 is 6, and 6 divided by 3 is 2. Do the same for the other dimension. New over original, new over original. Multiply by 2, across, divide by 3. 2 times 12 is 24. 24 divided by 3 is 8. You can have your new area by multiplying your two dimensions. And you have your new area over your original area. You can divide both the top and the bottom by 4 to end up with 4 over 9. If you were to square root 4, you get 2. If you were to square root 9, you end up with 3. So again, you see that the area scale factor is merely the linear scale factor squared or multiplied to itself, which completes the sentence. So the area scale factor is equal to the linear scale factor squared. Also, the square root of the area scale factor is equal to the linear scale factor. And that's all.